Hello and welcome to the video notes for AP Statistics covering sampling and how to collect data to make your sample. The reason I'm leaving it on this screen just to begin with, because I was clicking on my little thing up here to get my mouse, and I see this little thing popped up. What do you think of Pro Mouse? Thumb down or thumb up? We're going to talk about this and how this is not a good way to collect data. Just like in the airport when you walk through the line or whatever to get your visa stamped or whatever, and they have a little machine right afterwards that says, "How was your experience?" Happy face or frowny face, and they want you to hit it. This is not good ways to sample, but people do it all the time. It happens in the world, people trying to collect information. Here's why: because I don't have to do one of these. I can just do this and click it, and it's gone. I've just by doing that, I've made it a bad sample because they never got my opinion and they will never know what I think. That makes it a bad sample and it's not random anymore. So let's actually get to the notes. Simple random sample is the first one that we're going to talk about. And just like it sounds, it's simple. You just want to take your population, number them, or somehow identify them, all the elements, all the things in your population. And then you want to randomly select those. We usually say numbers because you need to randomly select those numbers. And we use like a random digit table, or we use the calculator to come up with a random integer or something like that. So yeah, random is the big key in all this. At least the goal should be firm in your mind that you're trying to represent your population. You're trying to get a smaller version of the population. So that's the goal in all these different techniques. So first one is just line them up, not really line them up, just number them and randomly select people. So maybe your population has a 10,000 people in it and you randomly select 100 of them, right? So you want to just make sure that you're randomizing it so that you get all types of races, all types of housing situations, all different types of incomes, all different kinds of opinions. You want every type of person represented, and this is the biggest problem when you're doing like polling for elections and things like that. People don't take into account that they need to make sure they cover everything in equal weight. For example, the whole, Trump and Hillary Clinton thing, they've realized that one of the problems with that, when they were predicting that Hillary was going to win and then she didn't, was that they were overestimating the number of people who were kind of rich, educated people. Because they're more likely to be online and they're more likely to kind of answer polls and things online, just like you saw that little pop up in the beginning. So they're more likely to do that. And those are usually the people who kind of affiliate with Democrats and who probably were going to vote for Clinton. The people who are voting for Trump and vote Republican are not as tech savvy. They're not as likely to answer online, just because of the way they are and who they are, right? So the type of people, maybe it's the income, low income, maybe things like that. So, or just rural people, right? So simple random sample, you just number them, you randomly pick those numbers, and then that becomes your sample. And you want to try to make sure you get everybody that you picked. You want to get as many of those as you possibly can. So sometimes you have to do follow-ups or chase them down a little bit, right, to get their answer. Anyway, that's one type, simple random sample. Big population, you take a sample of that, which represents that population. In my sample, I have males and females, and I have different races, and I have different opinions and ideas. I got old, I got young, I got everything, right? Okay, the next type is called stratified and clustering. There's two types there. So stratified, let's look at the first one, stratified. On stratified, you are trying to, well, let's take a look at this picture. It's probably easier to look at the picture. So you're trying to identify groups that are in there. And the reason you do that, you separate them into groups first. You can see we've separated them into like old and young and males and females and things like that, right? So old, young, female, male, or maybe you do it as race, like I want to have whites and blacks and, Hispanic or whatever. So you break them up on purpose because you want to make sure that you're including a little bit from each group so that you're ensuring that somebody from each group is having their opinion or having their whatever it is measured or kind of recorded, right? So we want to make sure that everybody is represented. So first we identify those things that are in there that are important, and then we randomly sample within those groups. So I might, pick these two guys, and I might pick this one girl and this, these two girls or whatever. So it's just randomly within those groups, you are randomly picking people out of there. And you would have predetermined this ahead of time. So if you have a whole bunch of, if you have like 80% white in your whole population and 20% of color, let's say, then when you break it up, you might have one group that are the whites and then another group that are people of color. So that out of the whites, you would pick 8, and then out of the people of color, you would pick 2 to try to make sure that the percentage is the same as the population. Remember, the goal is to get a sample that's representative of the population. You're not trying to, this is how people lie with statistics. If you want to skew the data one way or another, if you do it incorrectly, the data won't make any sense and it'll be worthless. But people still do it incorrectly and still use it, in the media and things like that. So you have to kind of analyze those things when you see them. And of course, we'll practice these problems in class, but that's the basic idea. So step 1, break it into groups that you think are important. Step 2, randomly select within that group, but do it in such a way that the percentages come out the same as your population. Right? So that's important. The other thing is you don't have to break down every single group that you can think of. You're only breaking down groups that you think could really mess up your data if you didn't include one of those groups. If you really are concerned about some kind of race issue or something, you want to make sure you separate people by race so you hear everybody's race opinion. If it has nothing to do with race, and then maybe you don't need to break them up by their race, right? That doesn't matter. So just leave them all mixed together, and the little nuances and stuff will, if you properly randomize your selection, those little nuances will come out because you are randomizing it and taking a good enough sample size. So that's kind of stratified, right? Now let's look at cluster, and then we're going to come back and look at some details real quick. So in cluster sampling, you are taking the whole population and breaking them into what we call heterogeneous groups. So within this one group, it's like a little mini population. You could think of this as like a little simple random sample itself. So it's like, here's a little random sample, here's another sample, another sample. You're not actually sampling these people. You are just cutting the population into small groups in such a way that it's all even, like it's heterogeneous. All right, each of these groups. And then you're going to go and you're going to census a whole group. So maybe I'll take this whole group and I will make sure that I ask every single person in that group, or I measure something about every single person in that whole group. So you do a census. I don't like that they put these little magnifying glasses on every single group, because you are not looking at every single group. You might do 1, you might do 2, because maybe you have you have like 10 or 20 groups. It's like you've broken it up that way, and you might just sample 2 of those, right? But remember, you're doing a census, and the reason you do a census is to make sure that you include every single type of race and gender and whatever, right? So you're just making sure you include everybody, right? Okay, so what are the pluses and minuses of these things? So when you do a stratified sample, it eliminates group bias a little bit, because you're making the groups yourself, and you're making sure that you get a little bit of each group in the same proportion as your population. So it really gets rid of those group bias. So if you think there's any bias in a group, you can automatically reduce that. The variability, this is a big one with Stratified, is you can actually reduce your standard deviation. If you group things by what's important and then do your sample, you will actually reduce the standard deviation. And we'll look at that in class, I think, as well. The downfall of this is that it's not truly, you're not going to get like every single possible combination that could have been possible in a simple random sample. The kind of the definition of a simple random sample is that anything could happen. I could randomly pick people and end up getting all females, and I never get any males, which isn't necessarily a good thing, but it's possible, right? So when you do a stratified, like you just don't have that option of everything is possible, which some people would say, depending on what you're doing, some people would say that's not a good thing. But when you know there's some kind of bias going on or possibly going on, then actually this is probably the better thing to do and not worry about that. Okay, so that it could possibly introduce bias just because you are assuming something in the beginning. So you might be kind of introducing some bias yourself by breaking it up in certain ways and not allowing that randomness to do its job. Because randomness is supposed to get rid of bias because you're just randomly picking. It should even out. If you have a good enough sample size, it should even things out, right? Where you're getting a little bit of everything is what randomness should do for you. So by not allowing all the possibilities, you're introducing bias. Okay, but the sampling variability, that's a one that comes up a lot. It's a very common thing we talk about. Okay, and then for cluster sampling, so if you do it by cluster, let's see here. So pluses, it's easier. If you have a bunch of different, like say you're a big conglomerate or something, you have a bunch of different companies all over Japan or Tokyo, and you don't really want to go and pick one person from that location and two people from that location and three people from that location. Then you'd have to like fly all over Japan and ask those people or measure something about those people, and that would just take too much time and money. So it's actually easier just to say, let me take this one company and I'm going to go look at that one location and just do a census within that location and just measure everybody in there and get my data that way. As long as you think that location is representative of all the locations, then that's not a bad thing to do, and it would save you time and money. Okay, so that's kind of the idea. Again, just like the other way, by doing a cluster, not all groups are possible because you can only, once I've decided to take this location, nobody else from any of those locations is going to get chosen. Or I can't have any kind of combination between like two people over here and one person over here and three people over there. That combination is impossible when you do it this way. So it's not a simple random sample, and you're kind of taking the chance that the randomness, has been hurt a little bit, right? But if you have a reason to do this, it's usually okay. So the big words are kind of heterogeneous and homogeneous. So maybe that will help you. But so clusters are heterogeneous. They're like small little populations, and you're just choosing one of those populations. Stratified, you're collecting your strata. Strata are homogeneous. You're breaking them into groups first, and then making sure you pick a little bit from each group. All right. And we will see problems like this in class. So if you're looking for more information, go see some of the other videos. All right, so there's a kind of a list here, which you could pause it and read through this of kind of the big points, but I think we talked about it. Okay, systematic sampling, just worth mentioning real quick. It doesn't come up that often, but let's say you want to go stand in front of a grocery store and ask people, how their experience was or how much money they spent today or something like that. Well, then you would you don't want to just ask every single person that comes out. I mean, you could, but to kind of get that randomness in there, like to make sure you're doing it at different times of the day, maybe, or you just don't want to pick every single person because you want that element of randomness in there. Sometimes you can do this. You could just say, well, I'll pick this person coming out, like the first person, but after that, I'm going to pick every fifth customer. The reason you might do this also is because you don't want your own brain to interfere. you might think that you're randomly picking people, but we can prove to you that when people try to randomly pick things, it actually comes out not random. You don't want to, you yourself in your brain, think that you're randomly picking things, because it doesn't work. It's a proven fact that people cannot pick randomly using their own brain. Okay, so you do it this way and just say, whoever comes out, every fifth customer, I'm going to take them and I'm going to ask them a question. All right, so that's what we call systematic sampling. Convenience sampling, this is a bad way of doing it. This is not a good way. This systematic isn't always the best way either, to be honest, but sometimes it's the only thing you can do. Convenience sampling is just bad. This is where you're just taking, like, often in stats class, if we give you a project and we say, okay, go collect data and I want you to go measure or go ask people a question or something, first thing everybody would do is run down to the book locker room and ask as many people as they can see. This is convenient sampling. It's not good because you're not ensuring that you got a representation of the whole population of students. You're only getting those people who happen to be in that book locker room during that time. And maybe they're there for a reason, like they all take the same class, of, like, they're all in BC calculus, let's say. So they're all, very kind of logical and intelligent type people who just happen to have the same free because they happen to be in BC calculus together. And you're asking all those people thinking they're going to be representative of all the ninth graders, 10th graders, 11th graders, and 12th graders, when obviously they wouldn't be, right? Because they're like in BC calculus. They're not going to be ninth graders, right? So it wouldn't be representative. So this is a bad way of sampling, convenience sampling, not good. Different kind of bias. These you need to know really well. Voluntary bias. This is what we were talking about at the beginning of this video, where that little thing popped up and said, give me thumbs down, thumbs up if you like my app or whatever. It's like that's a horrible way to try to get information, because I can choose whether to respond or not. It's a voluntary response. I can volunteer to respond or not. And so the people that tend to respond to these things are only those people who have strong opinions. People who really enjoyed their experience will hit the thumbs up, and people who really hate this program are going to hit the thumbs down. But all the people that are in the middle, you're never going to hear from them because they don't really care. So they just keep walking by and they never touch the button, right? So you're not gonna get that. So this is, all these biases are all these ways of getting data are introducing bias, and they're just bad ways of collecting data. Okay, so, and the type of bias you're putting in there. So this is bias. Voluntary response is bias towards those people who have strong opinions. Non-response bias. This is kind of like you send out a survey. That's another thing statistics students like to do, is they say, oh, go ask people this, right? So instead of actually chasing down the person and taking the time to do it properly, they'll just send out an email and hope that people reply to their email. This is, again, not a good way to collect data, because a lot of people won't respond to that email, and you'll get non-response bias. You'll be only getting those people who are interested in the topic that you've put forth, or who like you, or who are your friends, or happen to be in the same class as you. So it'll be biased towards those people, instead of making sure that you're including everybody in the whole population. Under coverage, this is the whole Trump and Hillary thing. The polls that people were doing were biased towards those people who tend to be online more and who like to kind of correspond online. So it favored Hillary a lot more than it favored Trump in the polls, because of this reason. They were undercovering. They didn't cover those people who are farmers and who live in the rural areas of Pennsylvania, who they don't like to get online and answer surveys because that's just the way they feel about it, right? You need to make sure you cover those people if you really want a true sample of your population. So that's undercoverage. And then response bias. This is where you yourself as a questioner influence what the person is saying. I might first ask you, like in class as a student, and I'm a teacher, I could ask you, like, do you ever take illegal drugs? I'm putting bias into the survey, because obviously not everybody's going to answer truthfully, because if they were taking drugs, they could get in trouble, right? So they're going to say, no, I'm not taking drugs. when maybe they were, right? So that's a response bias. So this kind of thing, you just have to be careful, very careful on how you word things. They've done many, many situations where just taking the sentence and just changing one word, or maybe flipping the what came first and what came second in the question, can really change the results. So this is a big thing right here. CNN and all these news things, they do this all the time. They will like have someone, a guest on their well, I'm going to say it in the news, but it's really just a TV show. They'll have them on, and then they will like ask them a loaded question. So don't you think that Trump is awful because of this and this and this? And of course, the person's going to say, well, yeah, Trump's awful because of this and this and this, instead of just asking him a question like, what's your true opinion? And what do you see, So on the fake news, uh, you're going to see this all the time, right? Where they load the question ahead of time. So anything coming out of that person's mouth is just an opinion, right? Anyway, so that's response bias. You can't affect the way people are going to respond by what you say first. Okay, sample size. This is kind of the last thing we need to talk about. The sample size thing. People always ask, like, how big of a sample do you need? And there's no one right answer to this. Often you'll see, depending what you're doing, often you'll see we'll talk about 30 or 50. If you can get up to 50, that's a good sample size. And that's kind of true for most things you do in statistics, for most normal things in the world. But you got to be really careful. If something is very likely to happen, like flipping a coin, it's very likely I'm going to get a heads. It's a 50-50. So that's 50% chance of happening. So my sample size wouldn't have to be that large before I would expect to get a heads to come up. I don't really only need like 2, maybe 3 or 4 flips, and I can see a head come up. Now they would say, or I would say to you that to get a good sample, you kind of want like you don't want something to just show up once. You want it to show up like 5 times. So if I think on average it's going to take 2 times to flip a coin and get a heads, one might be tails, the other one heads, but it doesn't have to be, right? They could both be tails. So to kind of ensure that I'm going to get a random kind of representation of what I expect to see, I want to make sure I flip that coin enough times that I get a good enough amount of heads and a good enough amount of tails to be representative of what's going on. So I don't want to just flip it twice. I want to flip it like 10 times, 2 times 5. So 10 times would be enough for flipping a coin to see the 50-50 split. You'll probably see it. If you flip it 10 times, you'll get 5 and 5 after a while. It might be 6 and 4, but you'll get a good representation. If I was rolling a dice, you would expect to only roll the dice one time, one time, could be anything. If I roll it 6 times, I would expect to see each one of those things come up, but not necessarily, right? I could get 2 2s and 3 5s. It's possible, right, to get some different combinations. So to ensure I see what's going on and I get a little bit of everything, I want to take that 6 and multiply by 5 and do 30 times, right? So if I roll a dice 30 times, I'm going to get a 5 in there, once, at least once, if not twice, right, or 3 times. So that's kind of your thinking, right? So we want to multiply by 5. So for example, if you're doing Yahtzee, if you guys know the game of Yahtzee, you take 5 dice and you roll them, and you're trying to get all 5 dice to have the same number. The probability of you getting a Yahtzee on the first roll is 1,296. So if I really wanted to see a Yahtzee come up, I would probably need to roll that thing like 6, 7, 8,000 times, maybe even 10,000 times before I can get like 2 or 3 or 4 Yahtzees to come up, right? I might even barely get one, if sometimes. So so sample size depends on your probability. And in chapter 4, the next chapter, we're going to get into, not chapter, but unit 4. We're going to get into probability and all these things a little bit more. But that's the idea. So it depends on your probability. However many times you think it's going to take, multiply that by 5, and that's how big your sample probably should be. Okay, that's it for notes. Again, if you didn't get all this right off the bat, then you need to go work some problems and watch those problem videos.